Today we're going to do Unit 10, Day 9, and the lesson today is very similar to the lessons for Day 7 and Day 8, except today we're not going to be able to factor through all the questions. For example, if you look at example 1, it starts out really nicely because you see you have a GCF. It's already set equal to 0. You're going to pull out your GCF of x, which is going to give you x times x squared minus 3x plus 1 equals 0. This side's easy. You know already that's going to be x equals 0. So that's going to be one of the solutions. On this side, though, if you try to factor it, you're not going to be able to think of two factors that multiply to 1 and add up to 3. There aren't any. It's also not a good candidate for complete the square because of this odd number right here with the 3. So we're probably going to want to look at this right side and do the quadratic formula for it. In the quadratic formula, my a is going to be 1, my b is going to be negative 3, and my c is going to be positive 1. So x equals negative b, 3, plus or minus the square root of b squared, which would be 9, minus 4 times a times c divided by 2a. I've written the quadratic formula at the top of the page for you, should you need it. If we simplify this, we're going to get x equals 3 plus or minus radical 5 over 2. And since radical 5 doesn't simplify any further, those are going to just be our solutions. So we're still going to get three answers. The first answer is x equals 0. The second answer is 3 plus radical 5 over 2. And the third answer is x equals 3 minus radical 5 over 2. And since each one of those happens once, the multiplicity of those is 1. On example 2, I checked out the trinomial and it had a GCF of x squared. So I already pulled that out here to x squared. If I think about separating these, this is going to be x squared equals 0, so x equals 0. But because of this squared sign, this 0 is going to have a multiplicity of 2. On the other side, we have x squared plus 6x plus 1. This, you could do the quadratic formula to this. You could also do complete the square. Since this is an even number, the 6, I like complete the square. Squared plus 6x, send the negative, or 1 to the other side is negative 1. And remember, you need plus and plus. To get this, you divide by 2, which is 3, and then you square it. So 9 and 9. When you factor this, it'll be something squared. In this case, it's x plus 3 equals 8. And then you could square root both sides. So when you square root this side, that's just going to give you x plus 3. When you square root this side, you're going to get plus or minus radical 8. If you simplify the radical 8, you're going to have x plus 3 equals plus or minus 2 radical 2. And to get the x to be alone, you're going to send the 3 over and make sure it's in front, negative 3 plus or minus 2 radical 2. So you have a fourth degree equation. You have three different roots. You have x equals 0, you have negative 3 plus 2 radical 2, and negative 3 minus 2 radical 2. But the 0 had a multiplicity of 2. On number 3, I've already set the equation equal to 0. And as I start looking for a GCF, I see one as 3x. So 3x comes out in front. That leaves me x squared minus 8x minus 2 equals 0. Now, the 3x is fine, but let's see if we can factor what's still left. Well, it's not going to factor. I can't think of any numbers that multiply to 2 and add up to 8. So on this side, let me change this for a second. On this side, we're going to have 3x equals 0. So x equals 0 on that side. And there's just one of those because it was 3 to the first, so the multiplicity of the 0 is 1. On the other side, you can choose to do the quadratic formula or complete the square. Again, since this 8 is even, I'm going to complete the square. Yes, you could do the quadratic formula if you like that better. So in completing the square, I'm going to have x squared minus 8x, and I'm going to send the 2 to the other side, which makes it positive. Remember, you have to add to both sides. Half of 8, or half of negative 8 is negative 4, but when you square that, you get 16, which means you also have to add a 16 to the right side. When you write this as a square, it becomes x minus 4. Over here, 2 plus 16 is 18. Take the square root of both sides. X minus 4 equals plus or minus radical 18. Radical 18 could be simplified to plus or minus radical 9 radical 2, which really makes x minus 4 equals plus or minus 3 radical 2. Now remember, you want x to be alone, so you've got to take this negative 4 and add it to the other side. So x equals 4 plus or minus 3 radical 2. On number 4, I've set that equal to 0. I'm going to take out a GCF of this time 2x to the third. That would leave me x squared plus 7x minus 5 equals 0. On this side, 2x cubed equals 0, which makes x cubed equal to 0. Taking the cubed root of each side, I'm going to get x equals 0. Now, because it was x cubed, I have a multiplicity of 3 on this side because it was x cubed. On this side, again, it won't factor. That's the whole point of today's lesson. Because this is a 7, I don't think doing complete the square would be a great idea. So let's do the quadratic formula. A equals 1, B equals 7, C equals negative 5. So x equals negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. So x equals negative 7 plus or minus the square root of 69 divided by 2. Now, since 69 doesn't have any perfect square factors in it, it cannot simplify. So I have 3 answers here. I have x equals 0. I have x equals negative 7 plus the square root of 69 over 2. And I have negative 7 minus the square root of 69 over 2. Because this was x to the third, this one had a multiplicity of 3. These just had multiplicities of 1 each. And if you add the multiplicities, 3, 4, 5, gives us back our x to the fifth.